Hi everybody and welcome to another tutorial video. In this video I'm going to try and explain to the best of my ability how my infinite multiplayer base works. I'm going to split this video into two parts, and this is going to be part 1 of 2 because I feel having one video would just take too long to explain. In this video I'm going to focus on the network manager. So I'll explain how all of the scripts in the network manager work, and then in part 2, I will focus on the position manager, local player, and cloud player sprites. So before I actually explain the scripts in the video, I'm going to try and explain how I made this multiplayer. If you first wanted to make a multiplayer game, you'd probably think of having a cloud variable for the player X, a cloud variable for the player Y, a cloud variable for the player 2X, a cloud variable for the player 2Y. And this would work, but it has some problems. By the way, I'm going to be explaining this video assuming you fully understand how cloud variables work and how variables and lists work, and also how you can make your own blocks. So imagine if you had two players. So you'd have player 1 and player 2. Now each player has their own cloud variable. So each player has their own two cloud variables rather. So it'd be player 1x and player 1y. And the same thing with player 2. Player 2 would have player 2x, and player 2 would have player 2y. So now the player 2x, they would have a random value. So say it's like, 32, -5. This could be, 42. So this would mean that player x is at 32, -5, and player 1 is at 32, -5, and player 2 would be at 42. So now say a new player joins the program. So the way it would work is, well, you'd have the two variables, and then the player would join. So what type of scripts could you actually write for this type of a program? Well, you can't just say, when green flag clicked, forever set player 1x to the x position and set player 1y to the y position. You can't do this because you don't know if there already is a player online. And if there was already a player online the program, and you were trying to set the player 1x and the player 1y, but another program was trying to set its own player 1x and player 1y, then the cloud variables would be overridden. So we needed to figure out some way to let the program know if there's a player occupying the player 1 slot and the player 2 slot. So if you think about this for a little while, you might say, okay, easy. I'll have another cloud variable. I'll call it like, player 1 occupied. And I'll set this to 1 whenever there's a player online. And I'll have a player 2 occupied. And I'll set this to 1 whenever the player is occupied. Now, you might say this, and then you can write an if statement. You can say if player 1 occupied is 1, then set player 1 occupied, if player 1 occupied is 1, then check if player 2 occupied is 1. If they're both 1, then it means I can't join. But if player 1 occupied is 0, or if player 2 occupied is 0, then it means I could join whichever slot player 1 occupied is 0. This seems like a good solution, but after a while you'll realize this doesn't really work so well. Because what if player 1 leaves? How will player 1 occupied be set to 0? Because you can't have a script that says, when I leave, set player 1 occupied to 0, because if the player left, the program stopped. It can't do anything. The same thing goes for player 2. If the player leaves, there's no way for the program to know that. So we have to use a concept called a watchdog timer. So instead of player 1 occupied, and remember that having the player 1 occupied and the player 2 occupied, this is not good. It's not a good solution because it just simply won't work. I've seen some cloud projects that, want to have something like a log off button. But this log off button is not a good idea because not everybody can press it. And if you don't press the log off button, the whole program will break, and you can't count on people pressing a log off button. So instead of having this, you'd have a variable, you call it player 1 watchdog, and the same thing here, player 2 watchdog. And the way a watchdog timer would work is if player 1 joins the game, it's going to say, okay, is player 1 watchdog changing? In other words, is player 1 watchdog going 0, 1, 0, 1, 0, 1? Right, I can't type it so well, but you get the idea. So if player 1 watchdog is switching between 0 and 1, then it means that there's a player in the program. If the player 1 watchdog is not switching between 1 and 0, in other words, if the player 1 watchdog is only 1 or it's only 0, then it means that there's not a player online. And the same goes for player 2 watchdog. If player 2 watchdog is at 1 and it's not changing, then it means that there's no player online. Or the same thing, if the player 2 watchdog is at 0 and it's not changing, then it means that there can't be a player online. Now that you hopefully understand this, I'll take you to a project I made in 2013, so it's relatively old, 4 years ago. This project is called Cloud Drawer, and basically it lets two players draw at the same time, using the method that I explained, a watchdog timer. So let's hit play. It's going to say waiting for a different player, invite a friend on. So in this project, I actually did a few things a little bit differently, but still very similar. So instead of calling the variable watchdog, I called it timer. And instead of setting the timer to 0 and 1, I just made the timer go up and up and up. So the program can tell if a player is online if the timer is changing. And that's the same thing, because if it's going up by 1, it's changing. If it's toggling between 1 and 0, it's also changing. So let's just run the program. You'll notice that P2 timer, or look, P1 timer starts going up. And that must mean that the player is registered as P1. So it says waiting for different player to enter the program, and it knows that there's not another player on the program because P2 timer is not moving. So this is basically the concept of a watchdog timer. If I were to start another program, the program would know that it has to be player 2 because the player 1 watchdog is being moved. And if I show this variable who I am, see, who I am is player 1 because it knows that the player 1 was not originally toggling, so now it's going to make it start cycling. So I used a very similar concept on my infinite multiplayer game, but there is one major difference between this project, Cloud Drawer, and my infinite multiplayer base. And this project, and this difference is that Cloud Drawer is not infinite. With Cloud Drawer, there can only be 2 different players. But with my infinite program, it can support an infinite amount of players. So I used the same idea of a watchdog, but I had to do it in a very different way. Also, there's a limit of 10 cloud variables for one project, so I couldn't make, 100 cloud variables and call it infinite, but in actuality, it would only support 100 players. First of all, that'd be very time-consuming, and second of all, it wouldn't truly be infinite. But the method that I used is actually infinite. So here we are back again in the Network Manager sprite. You'll notice if I go into data over here, I have a bunch of variables, but if I go to watchdog, I only have 2 variables, by the way, and this program still can do just as much, if not more, than my Cloud Drawer, which had 10 variables. This program does it all in 2. So anyway, you'll notice that right over here, I have the variable, and the variable is called watchdog. Now, it's a little bit blurry, so I can expand this stage. You'll see that over here, watchdog is just this, 1, 0, 0, 0, 0, and that's 10 digits. So let me just start the program. It hides watchdog, but if I hit D, it should show watchdog. It also shows position. So this is watchdog. It takes 10 seconds to see if any of these numbers are toggling inside of watchdog. Since these numbers are not cycling, then it knows that there's no player online. But you'll notice that the first digit of the number started changing between 1 and 0. You can notice that right over here. This is going 0, and then it changes to 1, and then it goes back to 0. And I have this delay set to 3 seconds. So every 3 seconds, if its own digit is 0, then it'll set to 1, and if it's 1, it will set it back to 0. So each player only needs to have 1 digit of the watchdog. And what I mean by digit is this is the first digit, this is the second, third, fourth, fifth, etc. So you'll notice that since this player ID is 1, it's toggling the first digit of watchdog. If I had another player join, I can start the program up, and I'll hit D so I can see the debug info. So the program sees, okay, the first digit is already toggling, so that must mean that some player is already online with a player ID of 1. So now this program knows its player ID has to be 2, because if its player ID was 1, then there'd be a major problem. If its player ID was 1, then it would be overriding all of the information that's in the position variable, and I'll talk about that a little bit later in the next video. So you'll notice now both of these are toggling, and also player 2 joined on our left screen over here. So if you look at the watchdog variable, you can see the first digit is 0. It should go to 1 in just a couple of seconds. There it goes. And also the second digit is changing between 0 and 1. And if you go back here to the first program, the first digit is changing between 0 and 1. And eventually the second digit over here, this will change to a 0 as well. And this is how the programs know how many players are online. All they have to do is see how many digits are changing between 0 and 1. See, and there it goes to 0. So if I were to make a third player join, the third player would say, okay, the first and second digits are both changing between 0 and 1. So that must mean that my player ID has to be 3, and I'll be the third player. And for example, if I move over there, the player moves on the other screen, and this is all achieved through these player IDs. Once the player ID changes, once the position variable changes, it knows to move there. So I use the same logic to tell when a player leaves. If the digit on the variable stops changing between 0 and 1, then it means that that player is no longer online. So you'll notice I close the second program, so this digit is remaining stationary. It's not changing back to 0. It's staying at 1. So the program will realize after 30 seconds, because that's my timeout, and there the player goes. It'll realize nobody's online. The player must be offline. So to illustrate this point just a little bit more, I have these two lists. These lists are called global used slots and global unused slots. So if we go on to global unused slots, you'll notice it updates every so often. Slots 2, 3, 4, 5, 6, 7, 8, 9, and 10 are all unused, and slots correspond to the digits on watchdog. So you can see that 2, 3, 4, 5, 6, 7, 8, 9, and 10 are all not changing. And in used slots, and you'll notice 1 is not here because 1 is changing. And used slots should technically have 1, but I made it exclude the the player ID that the own local player is. So it doesn't have 1 because this own player's game ID is 1. So if I make our player join again, it takes about 10 seconds to load because it looks to see if the watchdog variable is changing. So here goes the player, is loading, and he will join pretty soon. There it goes. Player ID is 2. So then it will try and update this watchdog variable over here. So then you can see, it went to 1. Then it's going to 0. And there's player 2. And look, use slots, player 2 appears because it now knows that player 2 is a use slot. So this is basically how the network manager works in a nutshell. And I know I didn't actually explain the scripts individually, but I'll do that in the next video. So this is part 1A of my infinite multiplayer base, where I explain the basics of how it works. The scripts themselves are a little bit complicated, but they aren't too hard to follow if you understand the core concept, the underlying concept of what a watchdog variable is and how it works. So thank you for watching this tutorial video. If you enjoyed it, please like it, and if you want to see the new parts, just subscribe to my channel and you'll see these new parts of the videos, and I'll explain in depth how this infinite multiplayer base. If you understand how the base works, you can make one of your own that's perhaps better than mine, and I'd be really excited and happy to see that. So thank you, and I hope you have a nice day.